Hello to everyone and welcome to another lesson of Ozone software. So at this lesson we will discuss resolution matrix and new options developed for it. So before I'll show you the options, I will tell a little about resolution matrix. Resolution matrix is analysis tool for inversion result. With this tool, you can check if you can resolve some targets for some depths and for some specified sizes. So mostly this tool can be used for post-analysis of inversion results or for construction of mesh, because sometimes if mesh parameters choose not proper, it leads to very bad resolution matrix for final model. Perfect resolution matrix means that it has only one value in vector. It's unit value, and all other values is zero. That means that this parameter, this specified cell, doesn't connect it to another ones, and this means very good properties of system. In this screen, on my screen, you can see the same field example I used in previous lesson, and we will check how resolution matrix looks like for this inversion model. One more thing, because it's very time-consuming process. I mean, calculation of resolution matrix. It's maybe really slow for large models, so I will show you how to make it a little faster. And the thing, I used very approximate solution. So it's not singular value decomposition, it's iterative solver. So it's much quick, but it's just approximation, very rough approximation of resolution matrix. But I think it's enough for analysis. So let's go. Here is model submenu. You can see new options, resolution analysis, and it's warned us that it's maybe time consuming. We will continue. So here is a progress of resolution matrix calculation in status bar. We should wait till it completed. And in this model, approximately 3,000 cells. So this is system 3,000 to 3,000 with 3,000 right side. That's a pretty big problem. But because it's iterative solver and not so many iterations, took us not so much. So here you can see three-section windows. This is resistivity model. This is integral resolution. So individual columns of resolution matrix. It's dot product, square root of dot product of these columns. And here is individual for every cell. So last one show us interaction of cells between, so some correlation, and so here you can see red one mean very good resolution, But here is perfect should be 1 everywhere. So if we make cells bigger, it should be more red. And here you can see individual resolution. Pattern, we can choose a cell and see how it looks. You can see it's more smooth and not intensive with depth. So the best resolution near surface, and it's all with the depths. Okay, here we can save all these results, calculated results. So this is how it's work. But if you have a very big, very large model, you can estimate resolution much quicker if you group cells. For example, now I grouped every 4 cells in one, and let's see how it will looks like. Now it's much faster, way faster. And you can see that resolution is, is more close to unit everywhere because size of cell 4 times more than it was previous time, and pattern looks not so smooth like it was, not only for first layer, but you can see that here resolution is better. So this is how it's work, and you can use it if you wish. And of course, it's calculated for this model, or we can see maybe some details. No, maybe just a little effect on this pattern of this border right here. Maybe it's better to change colors. Yes, now we can see some details generated by this resistivity section. Okay, thank you very much for your attention, and see you next time.